Okay, Fisher, here's the deal with yours here. I updated it a little bit, and that is a couple things here. You are using this SL, seconds left, which is fine, and I took your thing and commented it out because this is incorrect. You're taking the number of seconds and subtracting the number of seconds in a year and multiplying it by the number of years. But this is only if there's 32 years. That means if I put in the 9999999 answer, that's how that would work there. But let me see if I can comment this stuff out here. Comment lines here. So how yours is going to work, if I compile this and run it, and if I put in the exact number of seconds in 1 year and run it, let me move this up. It's going to give me a vastly different. It does give me 1971. That part is correct, actually. So do like that. But the number of seconds to left deal with is a negative number. That's totally incorrect. And it's a negative number because I put in a small number here, down here. And you've subtracted out a large number of seconds. So this is incorrect. You can't do it that way. This is only correct if there's 32 years. Okay. So and it looks like you made a good. What I want you to do is use modular arithmetic, though. Modular arithmetic gives us the remainder, so you don't have to do this subtraction business here. So this is this number of seconds divided by the number of seconds in 1 year. When I do that, it's going to give me the remainder of the seconds left over to deal with. So let me show you what that looks like here. Compile. Run. Now keep it in mind the rest of this is probably inaccurate. In fact, what I'm going to do is I'm going to comment this stuff out here. Well, it's going to be hard for me to come back. I'm going to ignore this spot over here. In fact, what I could do is I'm just going to work on months. So if I do this, comment lines, compile, run. So if I put in the number of seconds in 1 year, Command V, return. So it's 1971, that's correct. Seconds left to deal with is 0, so the month is 0. That's absolutely correct. So it still is giving me seconds left to deal with as a negative number, and that's probably because you have some sort of something wrong down here. Yeah, because you're using, I don't know. Okay, but anyway, that's incorrect. So if I put in, like, let's say if I add a 1 to this number, let me try. So compile. Oops, I don't need to compile again. So if I put in this number again, V, but I change this to a 5, that means I'm putting in the number of seconds in 1 year, 1 year worth of seconds plus 5 seconds. That should give me a remainder of 5 left over right there. So it's still a 0 in a month, but this would end up on the very bottom, the 5 seconds left over. So you see how this is working for us now for at least calculating the years with the number of seconds properly left over. And the reason why is because I'm using modular arithmetic. Mod means remainder, once again. I don't think you necessarily have to use a new integer value here. You could have just said seconds equals seconds mod this, and mod 31 whatever, 31 million. Because what that would do is just rewrite what's in the memory space for seconds, and then you could just keep on using the word seconds over and over again, just subtracting out little bits by little bit each time. So modular arithmetic, that's going to be your next thing that you're going to have to master. I would mess around with it a little bit, but you've got this. I think you can understand this. Just remember, modular arithmetic just gives you the remainder after a division problem. That's what we're looking at.